Okay. Um, Now, here's our problem. Um, okay, here's our problem. The mean score on a math quiz is 12.9, and 51.6% of students in the class scored between 12.2 and 13.6. Determine standard deviation of the quiz scores. So it's kind of a weird question. It's kind of forcing you to think about the ideas sort of in reverse. You kind of have to reverse engineer the solution, find out how did they get these numbers, and then we'll be able to see what that, hopefully, what that standard deviation is. So what we'll do is this. Here's our information, and let's see. I'm just gonna grab that screen and put it over here. I'm gonna use these tables too. Okay, so here's the problem restated. And so we start out with this. Think about what they're giving you here. Here's our distribution. Whoops. That was a little. Okay, here's our distribution. I just draw it like this. Okay, so we don't know what the z-scores are. That's the thing. But we do know that whatever's going on in here, between these two scores, Z2 and we'll say Z1, and the Z2 is associated with the 13.6 and the Z1 was the 12.9. I'll just write it like that. So those are the two numbers that came up, that would come up. And the area that we have here is the 51.6%. That's what's in between here. That is 51.6%. Now, it just so happens that these are evenly split. This distance in here is the same as this one from the 12.9. Sorry, this was 12.2 right here. Sorry. So 12.2, 12.9 in the middle, that's our mean, and 13.6. So when you set up your z-scores, when you try to find them, the 12.2 becomes 12.2 minus 12.9 over sigma. Well, that's negative 0.7 over sigma. And we're trying to find sigma. That's our standard deviation. Now, this 51.6% is the area that you would get when you calculate the area for this z-score, whatever area that is, from the table, and you subtract the area that is over here. Okay, that area comes from the other z-score, the one associated with the, we'll say 12.2, and this one is the area 13.6, that whatever that area was from the table. The difference between those is this 51.6. Now, what we like to see is this number in here. We know what this area is because this is exactly half in here. This 51.6 is divided exactly in half. That means that this part over here is half of the 51.6. Okay, so 12.9 plus the 0.7 is 13.6. Minus the 0.7 is 12.2. So this is exactly half in here, which makes this 0.258. Okay, so whatever this area is right here, we don't know what that is. We'll say that that's x. If you take x and you add it to 0.258, you should get 0.5. Okay, so that tells you that x is equal to 0.5 minus the 0.258. And that number is 0.242. So that when you look up this z-score, when you look up the z-score in your table, you will get this in the table. So if we look for this area in the table, we'll get the associated z-score. In other words, that would be this number over here. So let's do that now. Let's look that up in the table. 0.242. Let me just scroll up here. We know it's a negative number because over here, it's a negative z-score. We have a negative 0.7, so we're looking for a negative number. Let's go to the negative portion of the table, and we're looking for this number, 0.242. That's the area that's shaded red right in here. So let's find that. Let's see where. Okay, scan your table inside here. This time you're not looking at you're not looking up a z-score. You're starting with the area from a z-score. In other words, we're looking at this area in here, the gray part. So I'm seeing over here. Here's a 242 exactly right here, and that means z is negative 0.70. So that means that this number right here is a negative 0.7. So from this equation now, you can see that sigma must be a 1. So we've kind of reverse engineered the problem using this idea. Now we're fortunate to have this, to know this 0.258 because it was exactly half of this number, which divided this area in here half and half. So we knew that this area was 0.258, and we know that this whole half of this is a 0.5. So that gave us knowledge of this red tail in here. And once we had that, and we go look that up in the table to find the associated z-score. And then once we had that, we could solve this equation for sigma. It just happened to be negative 0.7. This would have worked whether this was negative 0.7 or whatever it was, whatever we found, we would be able to solve this equation. But key part of the problem was using the geometry of the curve here, knowing that the 51.6 was constituted halfway in here, the other half over here. That's how that area was divided. So that's how we knew that this was 0.258. If we didn't know that was exactly half, then the arithmetic might have been a little more difficult. I'm not sure what we would have done with that, but I'm not going to think about it. Okay, we got sigma equals 1 here. Okay, so kind of complicated, but a little bit trickier than the usual problem. So hope that helps.